Greetings and welcome, friends. We today are going to be solving inequalities, and since inequalities refer to values of a variable that are less than or greater than or less than or equal or greater than or equal to something, there will be lots of solutions. In fact, I might argue infinitely many solutions, and we're going to be solving these inequalities using very similar strategies to what we've done before, and you guys are already going to be experts at this. I can't wait. All right, so solving inequalities using addition. Just as you use the properties of equality to produce equivalent equations, you can use the properties of inequality to produce equivalent inequalities. That's weird. Equivalent inequalities are inequalities that have the same solution. So this one, and actually that's in terms of numbers. What am I saying? Here we go. Addition property of inequality. This is the idea. If I have an inequality, I can add something to both sides of it, and the inequality will still be true. True! Isn't that amazing? True. So great. Right? Just like when we had an equation, if I added 7 to both sides of an equal equation, right? It was still equal after adding 7 to both sides. Same thing works for inequalities. All right? Right here, I add 3 to both sides. Is 0 greater than or equal to -7? Yes! And here's it written algebraically. And they say, what's the difference actually between all 4 of these statements here? Why does it look like they said the same thing over and over and over? Yeah, the only thing that's changing is their inequality symbols. So they're saying it works for greater than, it works for greater than or equal, it works for less than or equal. It works for all of them. All of them. Yes, way. Yeah. Yeah, way. Yeah. Awesome. All right, here's a kind of number line explanation of the addition property of inequality. All right, so if I have A is less than B, and then I add C to A, right? So move C units to the right, and I move B C units to the right, my new points will still have a true inequality. That I could add C to both of those, and it will still be unequal in the end. Right? Good times, good times. So, all right, I know you guys are just like, Mr. Waddy, this is the slowest lesson ever. Let's get to the solving. Example 1. All right, tell you what, I'm going to have us do these. We got warmed up. I've got my cards. I'm going to have Devin. Aha. Devin is the first card. Could you help us with example 1? How do you think I could solve for x? You can? Devin, yeah. I want to get x by itself. How do I get rid of this 6 thing over here? Well, x is subtracted by 6. So the inverse would be to add 6. And I can't just add 6 willy-nilly. I got to add 6 to both sides of this inequality. And do you guys think that it will still be greater than or equal after doing that? Yeah, it's still going to work. I can add the same thing to both sides. And over here, these 6's cancel out. I'd have x by itself. Oh, man. -10 plus 6. This goes back to day 1 of our course. Well, their signs are different, so I subtract them. 10 minus 6 is 4. And who was more influential? Yeah, the negative, so it's -4. All right, let's see. Next student. Oh, Jimmy's not here. I'll fill in for Jimmy. And Amity, you're going to be after this question. You're going to be the next one. All right, so I want to graph this solution. So I'm going to I've got to have 0 in there. -4 seems to be the point of interest. And Jimmy, who's me today, is going to graph this, and he's going to tell us that, oh, a greater than or equal sign, the equal part tells me that it's going to be a closed circle. Solid dot, right, Cameron? That's right, that's right. And a greater than sign means I'm going to shade everything bigger than -4. And the bigger things on the number line are to the right because that's the positive side, and the smaller things are to the left because that's the negative. So I'm going to shade this to the right. Man, I love these colors. These are so great. Mr. Waddy, you're so good at coloring. Why, thanks, Jimmy. I am good at coloring. Wow. All right, so there's that one. That's right. No es más mal. Let's have I know. All right, so Amity's going to help us with question 1. All right, and I've got my number lines. I'm lining them up. Let's see. Line them up. Look at this. Look at this. Bam. Okay, so Amity just told me to add 2 to both sides. I'm getting the B by itself, so add 2. That's like a sad 2. It's not an add 2. It's all like squiggly. So I'm going to have B. Is it still going to be a greater than sign? Yeah. And Amity, what does the graph of that look like? Yeah. Is it open circle, closed circle? Does it have the equal part? No, so it'll be open. And the numbers bigger than -7 are going to be what? To the left or right? To the right, yeah, towards the positive x-axis, the bigger numbers. Let's see, Pooja, I drew your card next. Question 2. All right, so you're saying add 3 both sides. I'm going to have M. Is it still going to be less than or equal? Yeah, right? Like adding 3 to both sides, it's still going to be the same sign. And what's 5 plus 3? Ocho, yep. And let's see, so to draw this is 8. Where should I put my 0 and 8? Which one should be 0 here? Let's see, 8's going to be bigger than 0, so 8 will be to like the right of it. And what are you thinking about, solid or open circle? It's got the equal part, so it's solid. It includes the 8. So solid. And which way do you think I'm shading? Yeah, to the left. I like it. Man, awesome. All right, let's see. The card stack is getting smaller. Cameron, oh boy, you got the crazy problem, but don't worry. I'll like, this will be like a 2v1 double team. You and I we'll take this problem down. All right. Whew. Am I trying to get this by itself? What am I aiming for here? I probably want the... Yeah, so y is being subtracted by 1/4. All right, which is weird. It's got fractions. How do I undo subtracting? Addition. So let's add 1/4, and we'll add it to both sides. Okay, I'll help us on the fraction part. Let's see. 1/4 plus 1/4, you could say is 2/4. Right, 1/4 and 1/4 is 2/4. And 2/4, does that reduce anyone? Yeah, like 50 cents, which is half of $1, right? So that's half is greater than y. And then let's flip this around, just because that's weird. So y compared to a half. And while I flip it, I'm going to also flip this sign here. Watch that. See that flip? And so all of my solutions are everything less than a half. Watch how I do this number line, folks. I'm going to label 0. I'm going to label 1. Where do you think the half is? Halfway between them. Oh, it's so good. It's genius. Genius. All right. Cameron, you think open circle or closed circle? Less than. So it, open because it doesn't have the equal part. So it's open circle at a half. And less than, here's the positive x-axis, here's the negative. Which way do you think I shade towards? Less than, so to the left. Yep. There we go. See? El más fácil del mundo, friends. It's like the same thing you've been doing the whole time. It's just now there's a little inequality. Right? Alright, and guys, guess what? The subtraction property also works. What? And yeah, basically, all of this says, actually, Ethan, do you think you could summarize what this says? I know you didn't even have a chance to read it yet. But what do you think this is telling us? What is this? No? All right. Anyone think they could summarize what this is probably saying? This is saying if I have an inequality, then I can do this, and then this is... Anyone put into words what's going on here? Amity, what are you thinking? Yeah, could you describe what this is saying? What is the subtraction property of inequality? What do you think that would tell us? Or what it allows us to do? Yeah, it's basically saying if I have an inequality, I can subtract the same thing from both sides, and the inequality will still be true. All right? So it basically gives us the right to subtract from both sides. Let's take a look at this. Right? Easy lesson today. I'm going to cruise through this one. So guys, to undo addition, we subtraction 8 from both sides. Lovely. And why? Does it change the inequality? No, I could subtract 8 from both sides. Oh, it's not going to change. It's still going to be less than or equal. And what is 5 minus 8? Ooh. -3, I think. I agree. I'm just pasting some, oh dear, what did I do? What did I do? I'm just like getting some number lines in here for my notes. Because I'm so professional at this. I'll move that there and watch this. This is going to be great. This is the most entertaining video on the internet right now. Oh, I accidentally hit save rather than copy. There we go. Did I give you guys number lines on your end? Oh. All right. I just didn't help myself out. So my friend said -3. Y is less than or equal to -3. It's still less than or equal, right? It's great. So I'm going to have 0. I'm going to have -3. If you wanted, you could throw some more tick marks in there for -1, -2. You don't have to. Keep it simple, right? It's great. Closed circle, open circle. Raise your hand if you think it's closed circle. Yeah, closed circle. Why is it a closed circle? Anybody? Because of the equal part, right? And I shade it to the left because this little arrow is like pointing to the left, right? Less than to the left, right? That's the negative, that's the positive. All right. And over here, how do I get m by itself? This 1.4 is positive, so you could pretend it's being added. The inverse operation is subtraction. -1.4, -1.4. So that's like -9.4. It's becoming more negative. Is less than m, because these canceled out, right? And let's flip that around. So that means m, flip this inequality, is now a greater than sign. -9.4. Watch this. I'm going to break my 0 rule here. I'm going to make -9, and I'm going to make -10. And let's see how well I can divvy this up. So this would be -9.5. Right? And then if I do 1, 2, 3, 4. I think. I just want to point out, like, and that's the saddest distribution of, those are not even close to being the same increment. But Cameron, are you thinking open circle or closed circle for this one here? Does it have the equal part? No. What do you think? Open circle at -9.4. And, Devin, you think shade left or right? Go right. Man, we are solid on this. See, this is a perfect lesson for after vacation. Perfect. All right. Oh, let's do everybody's favorite, a word problem. Example 3. You guys can go back and do some of those monitoring progress later if you think it would help you. Here we go. All right. Oh boy. Scariness. Ooh, appliance and watts. Man, I popped a breaker switch just yesterday. It was all like, I had too many things running on it. It was crazy. All right, here it says, a circuit overloads at 1800 watts of electricity. Okay, all right. You plug in a microwave that uses 1100 watts of electricity into the circuit. Okay? Write and solve an inequality that represents, and watch this, the question is my variable. How many watts you can add to the circuit without overloading the circuit. So my variable, I'll say x equals number of watts, 1.21 gigawatts, that you can add. You can add. Bam. All right. All right. So that would be my variable. And instead of E for Visa for equation, it's going to be I because I'm going to write an inequality here. So my inequality, let's see if I can figure this out. They said a circuit overloads at 1800 watts. Overloads, that sounds like that's the maximum. So it's got to be less than that. So I'm gonna say a less than. It says at. So I'm assuming it overloads once it hits 1800, but 1799 is probably fine. You know, like the saying, 1799 is fine. No one ever says that. I just said it, but it's going to be the biggest saying of 2017. They're going to print T-shirts and hats. Hashtags 1799 is fine. So let's see, and we already have a microwave. Let's see. So 1800 is the maximum. So I know that I've got to be less than 1800. And the microwave is already plugged in. It's using 1100. And to that, I'm adding my X, right? Whatever I add, the number of watts I add, plus the 1100 of the microwave has to be less than 1800. So let's, did they ask? Oh, they said to solve. So let's solve that. S is for solve. All right, guys, you're the experts here. How do I get X by itself? You're the experts. Minus 1100 from both sides. The hard part is going to be writing the inequality, right? You guys are master solvers. So I'm going to have X is less than 700. Bam. Solved. And then I could answer, right, you can add at most, or no. How do I say that? No more, up to. No. Up to, but not including 700? Man, how am I not doing good at the words here? Yeah, but even like 699 and a half works. $700 watts. All right, but then they asked this question, question B. In addition to the microwave oven, which of the following appliances can you plug in to the circuit at the same time without overloading the circuit? So for part B, okay, so clock radio is an option. You could do clock radio plus blender is what you just said, because 50 plus 300 is still less than 700. I agree. Any other options? Well, just blender, right? Just blender. Hot plate, that's a no-go. Hot plate wouldn't even work on its... Oh, no. If I was going to say, would hot plate work if you unplug the microwave? 1200 is still less than 1800, so that would work. And toaster is a no-go. You trying to make toast at the same time? That's a no-go, friend. That's a no-go. Let's see. I think I'm good. Hopefully our internet friends are good. Tell us how you are in the comments below. We'll cheer you up with some more math. I'll reply with some of the best math videos to just make you so happy. All right, have a great day, friends. Bye-bye.